Hey guys, Mr. Rubo here. Going over the ambiguous case of law of signs. Just thinking about words, ambiguous meaning, there could be lots of options. We're just not sure on what it is. So this ambiguous case is when we have four possible outcomes. Okay, let me switch to my pen. Four possible outcomes, but this only happens when you are given a side, and an angle. Okay, so specifically one of those pairings, the angle's always got the side across from it. So it looks like this. And so what makes this ambiguous is that we actually have four possible outcomes. And they're listed here. Basically, if your A value, so if this side is too short, and if it's shorter than the height of the triangle that this whatever angle would make, then we have no triangle formed. So that one actually ends up being a lot less work, but we don't know it right off the bat. You either have to find the height, or you could just start doing law of signs and you'll see that it will not work. Okay. The other thing is we could have a right triangle formed, and that's when this A value is the same as your height. Once again, you can figure it out by finding this height first and then comparing it to A. Otherwise, when you do law of signs, you'll see you'll end up with a right triangle. Probably the easiest one to identify is if this A value is really large, and by really large I mean larger than this other B value, then we're always going to have one oblique triangle. And then the last thing is if A is bigger than H but smaller than B, then what ends up happening is we're going to have two oblique triangles. So I'm going to show you guys real quick a little demonstration that kind of shows this a little bit more interactively, if you will, than this picture does. So give me a second and I'll switch you over to it. Okay, so here's that animation I promised you. So if you can see here, we have an angle that's given, we have a B value that's given, and we have an A value that's given, so a side given. So you can see here, no matter if we swing this A value, because we don't know what angle C is, we swing it to be whatever angle, it's not going to form a triangle because this side's just too short. Okay, but as I increase this, you'll notice there we get a right triangle, and it only forms the one right triangle. Okay, but then as I increase it a little bit more, you can see that there's two triangles formed here. There's ACB2, so this larger one, and then there's AC and B1 that's also formed. So with this information, with the 30 degrees, the 9, and the 5.1, I could form two triangles. Okay, but then as I make A even bigger, as soon as it gets to 9, the same as B, you'll notice we have one triangle, and it just stays being one triangle because it's missing this side over here. Like, there's no way of creating a 30-degree angle if this A value is too big. Okay, so let's go ahead and get to some examples of this. Okay guys, so let's get into some examples here. So let's look at this one. So we can see we are given a side, and an angle. So if you're going to draw this, I would always draw them the same way, where the angle that's given is in the bottom left, 40 degrees. One of the sides, obviously not the side across, is next to it, and then the last side is here. Now you can always find the height, like that's always an option, and then you can compare it to the height. I like to just go right into law of signs, because if it ends up that there is more than one triangle, or even if there is any triangle, it'll save you a little bit of time in terms of solving it. So if we set this up, it'd be sine of 40 degrees over 4 equals sine of angle B over 10. We go ahead and solve this. Nice thing is we can just multiply by 10. Alright, and at this point, you would go right to your calculator, which I've got mine over here. Sine of 40 divided by 4, and then multiplied by 10, gives you this value of 1.61. Okay? Then at this point, you would take the inverse of sine, the only arc sine, to get b by itself, but if you try it, one, your calculator is going to spit an error back at you, because sine can't be greater than 1. So right here, this tells you that there is no angle B. So then, if there's no angle B, there's no triangle. Okay? So this would be an example where there's no triangle. Alright, let's move on to number 6 here. And with this one, same idea. I'm going to draw the same exact picture. 60 degrees. 9 is here. Oops. 9 is here, and 5.2 is there. So I go right into setting up the law of sine. So sine of 60 over 9 equals sine of B over 5.2. Multiply by 5.2, and when I do that, I end up getting, oh yeah, I should have realized that, 0.5. Alright, and then, this is actually one we should know off the top of our heads, but if we don't, inverse sine of 1/2 gives us 30 degrees. Okay, and then when you see this, you get a 60-degree angle, a 30-degree angle, so a triangle is formed, so we can finish off our drawing. So, then you know this is a 90-degree angle. So you get one triangle, and you know that angle C is 90, and then you could also figure out what this side is, either using your calculator or just knowing it's a 30, 60, 90. It would be 10.4. Okay, so if they wanted you to solve for the triangle. Awesome. Alright, so now let's move on to the next example. Alright, so for this one, same thing. Draw that triangle to start off with. Okay, so same triangle. Line's a little crooked, but that's okay. 8 here, 7 here. And actually this one, if you remember the little rule, this A value is bigger than 7, so right away I know a triangle is going to be formed. Okay? Ooh, pretend I can actually draw a triangle. That's okay. So I know there's going to be one and only one. So let's go ahead and do the work. Sine of 70 over 8 equals sine of B over 7. We multiply this out, so sine of 70 divided by 8, and you get about 0.82 for sine of B. So now we do the inverse of that, and we get roughly 55.3. Okay, so 0.3 degrees. Now at this point, this is something that, if you hadn't recognized that this was going to be just one triangle, the thing to realize is there's multiple sine values that would work other than just the one the calculator tells you. So if you remember correctly, if we talk about our quadrants, the 55-degree triangle would be right here, that reference triangle, right? But remember, sine is the y value, so the other quadrant that would also have that same y value is a quadrant 2 angle, where we would measure it from standard position. So to find the other possible angle for B2, you would always do 180 minus this quadrant 1 angle. When you do that, you get the 124.7 degrees. However, if we remember what's given to us, 70 degrees and 124 degrees cannot make another triangle. So, yes, this is a correct angle for B, but for this triangle, it doesn't work. So we only have the one triangle, and we can solve for the rest. Okay. So this last example here, same idea, and you guys could probably guess what's going to happen. Because I want to show you all the stuff. So this is 2, this is 3, so this is not bigger than this, but we don't know if it's bigger or not than the height, because I don't draw a line to scale. So let's go ahead and do some work. So sine of 40 over 2 equals sine of B over 3. Multiply it out, so 3 times sine of 40 divided by 2 is 0.96 equals sine of B. So then we do the inverse sine, and we get that the first B value that's possible is a 74.6 degree angle. Alright, so once again though, because you have a 74.6 degree angle, there's also one in quadrant 2 that would also work. So B2 would equal 180 minus 74.6, and when we do that, we see that we get 105 degree 0.4 degree angle, I should say. And so there, when you look and you add it to 40, you can see that it is clearly under 180 degrees, which means two triangles are formed. So then, this then requires you to do twice as much work. So you would have to find C1, the angle C1, and the side C1. But then you'd also have to do the same thing for the second triangle that's formed. So you're finding C1 and C1, the side C1, and then angle C2 and and side C2. All right. So this right here is your ambiguous case of law of sines. Hopefully you guys enjoyed it. Have a good one.